Hello. We're going to cover all of South Pole-Aitken, not just the South Pole. My colleague and I, Jim Head, have a number of things we'd like to make sure you're aware of. Notice, of course, that South Pole-Aitken is 2,500 kilometers in extent. This is big. Well, how big is that really? Well, okay, here's something that you should recognize. We are right nestled up against the Rocky Mountains. 2,500 kilometers is the distance from San Francisco to Kansas City. And you can see it's very diverse, right? Geology is very complex. So where would you go to obtain a representative sample of South Pole-Aitken? Or what? Maybe it's easier. How about 2 samples? Well, not quite. Maybe 6. That's what we did with 6 different Apollo sites. That starts making it reasonable. So obviously, there's not one place to go in South Pole-Aitken to get what we want. And I'm going to talk about just a couple of places, which isn't the whole story, but which at least gives you a taste. Okay, another fun fact though, since we're here at the Rocky Mountains, SPA is 6 to 8 kilometers deep. The Rocky Mountains are the highest part in this system, and they're only 3.6 and 4.4. So SPA is deeper than the Rocky Mountains are high. Fun fact. Okay. Let's go on and look about what's inside South Pole-Aitken. During LPSC, Jim and I talked about 7 different sites that would be of very important interest. In this talk, I'm only going to talk about 2 of them. And I'll start with the SPA impact melt. All of these areas are important and extremely valuable, but in the interest of time, we'll talk about 2. So SPA impact melt. How do we know where it is? Well, here's a nice map that our German colleagues, with some of their colleagues, have been developing of the South Pole-Aitken. These are more or less at the same scale or same perspective. Let's look at this in more detail. What we're interested in for the impact melt is some of the oldest exposed surfaces. In other words, the pre-Nectaran floor material. And circled in red, the general areas those are located. And you can see it's very complex. There's not one place, okay, go there, you've got it. But there is a place where there's a concentration of these kinds of terrain that are some of the oldest pre-Nectaran terrain exposed within the basin. Okay, what do these look like? Well, here's the comparison of where these pre-Nectaran areas are, or at least the concentration of them, relative to the topography that we're all familiar with. And you can see, yes, that makes sense. Many of the other areas have been altered by major impact events. Some of them have been resurfaced with basalts. There's some of them that have been resurfaced with the material that appears to have blanketed much of the interior right after the event. So we understand a few of the areas, or at least we can target some of the regions that will allow us to obtain a high probability of obtaining some of our desire for impact melt, which is, of course, desired in order to date the basin. Is it 4.1 years? Is it 3.9 years? It's probably the closer to the earlier, but we need samples in order to actually understand when did this largest basin on the moon that is identified, when did it occur? It sets the whole time scale for the early part of the solar system. Okay, let's now talk about diverse basalts. I've only chosen one place to talk about, but it's one of my favorite basaltic areas. It's up in the crater Thomson, which is within the Mare Ingeni, which is a basin itself, which is within SPA. So if you sort of look through that sequence, there are three major impacts: SPA, Mare Ingeni, and then Thomson. And Thomson's a 100-kilometer plus crater that has excavated into the interior of the moon. Now, it's been filled with basalt, so that's why it's on this basalt terrain to sample. But one of the reasons I also like this as a place to obtain basaltic material is the rim also exposes some of what many of you may recognize, because I've talked about it before, a magnesium spinel anorthosite, which has been discovered largely through remote sensing. But we know there are now concentrations of it in several areas on the moon. And within the South Pole-Aitken Basin, this is the one area, they're highlighted in green little specks around the rim of Thomson crater, that allows us, if I had a pointer going up to the end of that green arrow and into the basaltic terrain, that would be a perfect place where we can not only get basalt, but assume we can get some downslope material from this principal kind of material that we have not sampled in our sampling of the moon yet. Okay, I think I'm okay. That's my story. I could go on forever, but I'd like to tie it back in with several things that have already been discussed today, namely the wonderful Endurance A mission that is so strongly recommended by the Decadal report. The two areas I were talking about are in the little dotted ovals there. The top one is Thomson crater, which is a wonderful basalt, but also gives us access to this magnesium spinel. And the second is a region that, and this would require more detailed analysis, where in that large oval, but that large oval has a high concentration of some of the oldest terrain that's exposed within South Pole-Aitken Basin, and which should provide us with information on the impact melt, which can date this largest, deepest basin on the moon. Thank you.
Thank you very much.